All right, ladies and gentlemen, part 3, third installment of our Law of Sines videos. Now this one's interesting because just like our last example, we do have a two-parter here, but it's a combination of a right triangle or right triangles and non-right triangles. So quickly, just to kind of highlight, we have the outermost triangle, which is a right triangle. Hypotenuse is 16, right? So remember, right triangles, we should use traditional SOHCAHTOA. What else do we have? We also have another right triangle in here, triangle EFG. All right, we don't have any side lengths, but we should be able to get the angle measures there. Okay, but then finally we have this little sliver of a triangle here, which we're going to find out is not a right triangle. So if I want to use or find any bits and pieces to that, then I definitely want to use Law of Sines. All right, so let's dive in. They want two different sides from us. So let's see, they want GH. So let's start with GH, and I'm going to use a blue pen for GH. So GH is here. Now, again, I'm not going to use E because I'm not sure which E we're talking about. So I'll just put an X here. All right, so let's see. Can we get that right away? Oh, yes, we actually can. All right, let's go dive in and say, well, these two angles here form a linear pair. And we're going to take 180 and subtract 59 from it, and that leaves us with the supplement to it, which is 121 degrees. All right, as a matter of fact, let's keep going through and find all of our angles. So 121 plus 22 should give us a total of 143, and when we subtract that from 180, that gives us 37 degrees up here. All right, cool. Now we also have one more angle to find, and I'm going to basically just use the remainder of 90 and 59, which will leave us 31 degrees. All right, cool. So we have all of our angle measures. Let's see what happens here. So the first example is actually going to be very quick, I think. We can just use that sliver of, we can use triangle EGH and the Law of Sines just to find X right away. All right, so here we go. Let's go ahead. Like I said, I'm going to use the blue ink for this one. So let's start our Law of Sines equation. Now, here's my 121 straight across from 16. So that's going to get me started. So I'm going to have the sine of 121 is to 16. As now I got to find what angle is straight across from X, and that's going to be 37 degrees. So I'm going to have is equal to the sine of 37 degrees over X. All right. Again, I'm going to skip ahead. All right. I'm just going to show you my steps in solving. All right. But you can pause the video and check my steps out if you want to slow it down. Okay. I've skipped ahead a little bit, and I just want you to understand that we wrote our proportion, our Law of Sines equation. Then we cross multiplied. Then we divided by sine of 121 to get our side or X alone. And now I'm at the point where I need to type in my calculator. After typing in my calculator, I'm getting approximately 11.23, right? Because it's 11.233, etc. Now I'm going to zoom back out and let's just see if our answer makes sense. So let's see here. Yeah, I think it does, right? We have an obtuse angle straight across from 16 kilometers. And now we have a smaller angle of 37 forming a smaller side of 11.23. So at least it makes sense. So far, so good. As a matter of fact, I'm going to replace X now with 11.23. Okay, there's our first missing side. That was side GH. So now I'm going to put 11.23 and label it with our units. All right, next part. I'm going to use purple for this one. So now they want us to find EF. All right, so as a matter of fact, guys, listen, I don't even need 11.23. It's a little different than the last example. What I'm actually going to do is I'm going to highlight the outermost triangle, right? I don't need to use the Law of Sines because that triangle by itself is a right triangle. So I'm not going to draw the whole thing, right? But I should at least be able to envision that this is 16. This is 22, and I'm looking for the side that's straight across from it, right? EF. So I'm just going to use straightforward traditional SOHCAHTOA, all right? So I'm looking for opposite when I have the hypotenuse. So in this case, I'm going to solve a sine of 22 degrees equals x over 16 equation. All right, our variable is in the numerator. We're going to end up getting x equals 16 sine 22 degrees. And after typing in our calculator, we get a side length of approximately 5.99 kilometers, okay? So I'm going to go ahead and put that in my answer space, 5.99 kilometers. And once again, let's just make sure. Yeah, I think so. I think that makes sense, right? 16 was the hypotenuse. 5.99 is across from a smaller angle, 22 degrees. I think it makes sense. There we go, ladies and gentlemen. One law of sines and one SOHCAHTOA equation.